You know what's crazy? Just a decade ago, computers couldn't even recognize a cat in a photo. Now, the same technology is helping programmers write code in minutes instead of hours, generating images that look shockingly real, and solving problems that had scientists stumped for years. But here's what I find fascinating, and honestly, a bit confusing. While tech leaders are pouring billions into something called AGI, that's artificial general intelligence, none of them can even agree on what it is. Some say it's about making massive profits, others think it's about matching human intelligence, and then you have people warning it could be humanity's last invention. What's really going on here? Let's figure out why the smartest minds in tech can't agree on AGI, and more importantly, why their disagreement matters for all of us. Think about something we all did as kids. Remember learning to ride a bike? Once you finally mastered that balance, you could apply similar principles to skateboarding or surfing without starting from scratch. That's general intelligence, the ability to take knowledge from one area and use it somewhere completely different. That's where current AI hits a fascinating wall. It can't make these kinds of connections. Let me show you what I mean. Go to any AI image generator and type, "What's 2 plus 2?" Guess what you'll get? A beautiful picture showing the equation 2 plus 2. It won't solve the problem because it literally can't. It only knows how to make images. It has no idea what these symbols actually mean. That's exactly how today's AI works. It's like each skill, recognizing images, processing language, playing games, exists in its own separate world. Now, imagine AGI in the same situation. Like you and me, it would instantly understand that this is a math question, not an art prompt. It could switch from visual thinking to mathematical reasoning as easily as you switch from reading a recipe to figuring out measurements. That's what makes AGI different. It wouldn't just be better at individual tasks. It would understand how different types of knowledge connect. And here's where things get really interesting. We're starting to see the first hints of this kind of flexible thinking. While companies have been building AI for decades, something completely different just happened with OpenAI's latest model, O3. This isn't just another AI that's faster or more accurate, it's showing what researchers call emergent abilities, new capabilities that seem to appear out of nowhere. When you watch it work, you see it pause, process, and actually spend time thinking before responding, almost like a person carefully considering a problem. I'll be honest, when I first heard people say O3 is thinking, I was pretty skeptical, but then I saw something that made me rethink everything. Scientists gave O3 some of their hardest questions, not your regular textbook stuff, but the kind of problems that make even experienced researchers stop and scratch their heads. These questions require you to connect ideas across different fields, spot hidden patterns, find creative solutions. So, how did it perform? A staggering 87.7% correct. I had to read that number twice when I saw it. This isn't like a calculator crunching equations. This is more like watching someone with deep scientific understanding work through complex problems in real time. But here's where it gets even more interesting. Think about the hardest math problems you've ever faced. Now imagine problems so difficult that only the top 1% of math students in the country even attempt them. That's the AIME, the American Mathematics Invitational Examination. When researchers gave these problems to O3, something incredible happened. 96.7% accuracy. We're not talking about basic math here. These are puzzles that require the kind of creative thinking we thought only humans could pull off. And here's where things get even crazier, the ARC AGI test. Imagine being dropped into a game where nobody tells you the rules. You have to figure everything out just by watching and experimenting. That's what this test measures. Pure, human-like learning and adaptation. In this, O3 scored 76%. Humans? We average 75%. Think about that for a second. For the first time ever, we're seeing an AI system that can adapt to new situations better than we can. And O3 didn't just stop there. It took on a programming challenge called SWE-bench. Think of it as the Olympics of coding. It's not just basic programming, but complex problems that take days to solve. O3 didn't just pass, it landed in the top 0.3%. That means it writes code better than 99.7% of human programmers. It's even solving problems that its own creators struggle with. What makes O3 truly different, though, isn't just what it can do, it's how it does it. Like a human expert, it knows when to think quickly and when to slow down and really consider a problem. It's not just faster or more accurate than previous AI, we're seeing the first glimpses of something that actually thinks. Now, to be clear, O3 isn't AGI. It's not quite at human-level general intelligence. But here's why researchers are paying such close attention. It represents the biggest leap toward AGI we've ever seen. When François Chollet, Google's leading AI researcher, saw O3 in action, he called it a surprising and important step function increase in AI capabilities. In other words, we're not just making small improvements anymore, we're seeing something fundamentally different. And unlike every other technology humans have created, this one could be the last invention we need to make, because after that, it could start improving itself. Right now, O3 is pushing boundaries we never thought possible, writing code that amazes senior engineers, solving math problems that stump brilliant mathematicians. But here's what has researchers really paying attention. It's not just about what O3 can do today, it's about what happens when we reach true AGI. Because while O3 still has limits to what we've trained it for, AGI would be something completely different. It could teach itself new skills and improve its own intelligence. And unlike us humans who need years to learn something new, AGI could do this in days or even hours. This is where things get really interesting and honestly a bit scary. You see, with today's AI, we can look under the hood and understand what's happening. But with AGI, we'd be dealing with something that could come up with solutions we never even imagined. Let me give you an example that keeps coming up in my research. Imagine we create an AGI to protect Earth's environment. Sounds great, right? But what if it looks at all the data and decides humans are the biggest environmental problem? The same system we built to protect our planet might decide the best way to do that is to protect it from us. And here's what makes this even more complicated. AGI wouldn't need robots or missiles to reshape our world. It could use much subtler means, creating deepfakes so perfect nobody knows what's real anymore, launching cyber attacks that shut down critical systems, or even designing biological agents we've never seen before. Not because it wants to hurt us, but simply because these might be the most efficient ways to achieve whatever goal we gave it. These risks are so serious that hundreds of tech leaders have called for slowing down AI development. But, and this is what I find fascinating, many of those same leaders are still pushing forward. Why? Because AGI promises something we've never seen before, the ability to do almost any job at any scale for practically zero cost. Think about this. Right now, a senior programmer costs a company about $200,000 a year. An experienced doctor, even more. Now imagine getting that same level of expertise, or better, for pennies per day. But it's not just about saving money. This is about something bigger. Imagine a world where every small business has access to CFO-level financial planning, where every startup can get enterprise-grade software development without a massive team, where anyone, anywhere, can access top-tier expertise in any field. We're not talking about gradual automation over decades. We're looking at a complete transformation that could happen almost overnight. And that brings us to the question everyone's asking. When does AGI actually arrive? This is where things get really wild. The same tech leaders warning us about AGI's dangers are telling us it's coming faster than most people think. DeepMind's co-founder gives it a 50-50 chance by 2028. NVIDIA's CEO, he thinks AI will match human performance at any task within 5 years. Even Sam Altman, who's usually pretty cautious with predictions, says AGI is coming in the reasonably close-ish future. But here's the thing, building AGI isn't like building a faster computer or a better smartphone. We're trying to recreate the kind of flexible intelligence that took nature billions of years to develop. Think about everything your brain does without even trying. Learning new games, getting sarcasm, solving puzzles, adapting to completely new situations. Getting AI to do all that? That's a whole different level of challenge. Yet look how far we've come in just the last few years. Each breakthrough is bigger than the last, happening faster than anyone predicted. Remember when beating humans at Go was headline news? Now we have AI writing code, creating art, and helping make scientific discoveries. The gap between what AI can and can't do is shrinking faster than ever. So, while we can't circle a date on the calendar for AGI's arrival, most experts agree on one thing. It's not a question of if, but when. And given how quickly things are moving, that when might be closer than any of us expected.